minimum value, right? So according to the definition that you can just understand that what is the maximum value or minimum value. That means for the domain all x, if you just use any x in the domain as the input for the function, no one will larger than this number. No one will larger than this number. At most, they just equal. They are just equal. Then we will say this is the maximum value. So likewise, if you want to understand what is the minimum value, that means no any x in this domain. When you just use x as the input for the function, then the value you get is always larger or at most just equal to the value. Then we will say this is the minimum value. Okay, so I will show this one. So let's just continue. Today we will continue to know more about extreme value. So then we already know what is the just wait. Okay, so right now we already know what is the extreme value. Then we will go to so-called local maximum value or local minimum. So compared to extreme, global, compared to this, we have global maximum and minimum. So you can see local and global. That means that based on this idea, actually we are talking about its relatively extreme value. So I just give you a formal definition that if a function f of x has a local maximum value at an interior point. So remember, this is for interior. Did you still remember what is interior? If we are talking about an interval that they just include two types of points. One is the endpoint, like A and the B, right? And we also have some internal point that means for this interval, we just exclude two endpoints, and all points will be the interior point. So in this case, we just talk about if we just at some interior point, we can get the local maximum value, then it should follow that in this domain, if f of x less than f of c for all x in some open interval containing C. So that means, for example, in the past, if global, we will focus on all domain. However, if for local global, that means, for example, just like this, x and y. Okay, so if this is y is equal to f of x, so when we say, in this case, we are trying to find the local maxima, right? So local means that local. Okay, no. Okay, maybe we can just focus on this point, C. So C, you can see this is a local. We can have local maxima here. However, it's not global maxima because you can see another point here is higher than this point. Okay, so if we're talking about global maxima, it should be this point, right? But if we talk about local maxima, we will talk about this point as well as this point. So based on definition, you can see if all f of c is here. So if you can find in some open points, open interval, okay, open interval means here, right? So if you can find open interval which contains C, then all x means here, this point. For those x, when you just use this x as an input for the function value is less than or equal to f of c. So you can see it's just a local kin, right? It's not a global kin. Okay, so similarly, in this C prime point, then you can also find an open interval for any point inside the interval which contains C. Then its function value f of c is also larger than or equal to all other x here, right? So that means no point in among them can be larger than the f of c. So we will say, okay, C prime, we can get the local maxima. But if we want to get the global maxima, you need to pick all local maxima to compete for the global maxima. Right? It's reasonable, right? Like in our department, we have three classes for each level, right? So if we want to, for example, each class, we can just get the number one with the maxima score in each class. But can I say this one should be the maxima one for the whole department? No, because we need to come among different classes. We need to compete for upper level number one, right? So can you understand me? So just like in our department, 在我们系上，我们是不是3个班？好，假如我们班，我们现在有甲乙丙，我们这是偶数奇数了哈。但是如果我们班上有甲乙丙3个班呢，每一个班呢，它有它的自己的第一名，对不对？但它未必是全系的第一名，它也未必是全校的第一名。为什么？因为它只是区域上少数几个人都输它而已。这样了解这个意思吗？所以比较 formal 定义应该是这个样子哈。但是直观上来讲，我相信你应该有那个直观的理解哈。Okay. So similar, if you want to talk about local minimum, then we just change the direction. Then you can get a similar definition for the local minima. Okay. So then we just go for the first important theorem. The first, there's a theorem that we can try to use the first derivative theorem for local extreme values. So it's obvious. This theorem just try to use first derivative to get the local extreme. to get the local extreme. So the theorem just described like that if f of x has a local maximum or local minimum value at an interior point. Remember, this is focusing on interior point. And if f prime x is defined as C, we can conclude that f prime of C should be 0. This is very important. Okay, let me just repeat again. So if at some interior point, we can find the maximum value or minimum value. If it's differentiable, that means we can find the derivative at this point, C. Then we can conclude f prime of C should be 0. Should be 0. Okay, so let me just put it. If f of s has a local, this time we just take local maxima as an example at s is equal to C. Therefore f of x must be less than or equal to f of C, right? For some certain open interval, that we can guarantee that f of x must be less than or equal to f of C, because f of x can obtain the local maximum value at s is equal to C. Okay, so it's quite obvious, right? So that means we can also get f of x minus f of C should be less than or equal to 0, right? So that's no problem, right? That's no problem, because we have this inequality, so we can conclude this one. We just simply move f of C from right hand side to left hand side, so we can get this one. Okay, so okay, then we just can start to consider that 2. If we consider to limit s is approaching C plus f of x minus f of C, s minus C, and we also consider limit s is approaching C minus f of x minus f of C divided by f minus C. So what are we doing? We are trying to get the is to n limit, right? Is to one-sided limit. This is one-sided limit from right hand side. This is one-sided limit from the left hand side. If the limit exists, if the limit exists and these two limit values are the same, then based on the f prime x is defined, that means it is differentiable at this point. So that means it's two one-sided limits exist and also the same, right? 我们很快讲一下哈。他说 f prime s 在 C 是有定义的，代表什么？在那个点存在微分值。如果存在微分值代表什么？所以我们不断的复习大家有没有？存在微分值代表什么？它必须要这个的单边极限跟这个的单边极限，这个比值的单边极限存在且要相等，对吧？哦，这个是微分的定义。微分的定义是在讲这个的单边导数要存在，这个的另外一边的单边导数要存在，而且要相等，我才可以说它在 f prime s 在 C 有定义嘛 ？f prime s 在 C 有定义，就是隐含着它的双边导数。OK， 这件事情相当于什么 ？Limit s is person c f of x 等一下 ，from c f of x minus f of c s minus c， 这个是要存在的嘛？那这个是什么？这是一个双边极限。双边极限我会把它拆成两种，从左边从右边过来，从右边从左边过来，这两个应该要存在且相等，它才可以满足这件事情嘛。你既然跟我讲说它是可微分嘛，对不对 ？OK， so let's just continue. So in this case, f of x minus f of c is less than 0 or equal to 0. So that means here should be less than or equal to 0, right? So same here, right? But how about this one? S minus c is positive or negative? This is positive or negative? Positive, because S is approaching C plus, right? A little bit more than C. So when he subtract C, then it should be positive, right? So similarly for this part, it should be less than 0, right? So based on this, we can know, based on these two ones, we can know it should be less than or equal to 0, right? Based on this, it should be larger than or equal to 0, right? So if we want to have its double-sided limit for this form, then only, you can see the only common term is 0. Only equal. That means only 0 is possible. So that means based on these two ones, we can conclude that f prime c is equal to limit s is upon c f of x minus f of c divided by f of c should be 0 only, because this exists, and when we just analyze it from two aspects, one is from c plus, one is from c minus, then this part will be less than or equal to 0. This part is larger than or equal to 0. So only 0 can be accepted. Right? Only 0 can be accepted. So that would be should be C. Be 0. Because only 0 is accepted by, if I say this is 1, this is 2, and 2 at the same time, right? So finally, we can conclude that f prime c must to be 0. Okay, we also can understand the concept in a very intuitive way. You can see, if we can have maximum value, that means around the point, they always, maybe either climbing up, then after pass the point C, then we are going down. So when you're going up and going down, there is a turning point. Its tangent should be horizontal line. So likewise, if we just have a local minima as C, that means the curve should follow going down. Then after passing C, that C is the turning point, then the curve will going up. So you can see when we pass C, then there is a tangent point, a tangent line through C. So the tangent line is horizontal. So that is the relationship should be 0. Okay, so it's also very intuitive, but that is just happen at the interior point. OK， 所以我刚刚很快的讲一下，就是说，除了你从这个角度来看，从理论的分析来看，它真的只有0可以接受，因为它必须要 两个双边极限要存在，我们两个共同的公约数就是0了，因为一个是大于等于0，一个是小于等于0，我们两个可以接受的极限就是0，大家非得要0才两边都可以，因为你告诉我它是双边极限存在，因为你告诉我它导数存在，了解吗？好，那我们再用一个很直观的想法，如果它这个函数是个连续函数，你想一想，它要产生极大值，它一定有一个什么过程？在它之前一定有往上爬的动作，碰到它开始往下掉，这个才是会有极大值嘛，对不对？同样的，如果是极小值人往下跑，经过它的时候要就往上升了，对不对？所以在一个上升到下降或下降到上升的过程中，我们会经过一个转折点，就是 C。在经过 C 的转折点这个瞬间的时候呢，它一定是水平的。还记不记得我们在讲导数的时候讲的5件事情，它是同一件事情，包含一件就是经过这一点的切线斜率，事实上就是这一点的导数，有没有？这个精髓就是告诉我们这个整个现象。所以如果经过这一点是一个水平 ，OK， 它的导数自然而然就是因为它切线是0，切线斜率是0，它导数也是0。OK。我只有把一些比较重要的观念要让人家搞清楚的时候，其实从理论的从直观的，我们就尽量讲清楚，但没办法把每个细节讲得这么细OK, so that I just want to give you a note. So the only places where a function f of x can possibly have an extreme value, either local or global. So what places? The first one in the interior point where f prime s should be 0. The second one is the interior point, but where f prime s is undefined. The third one, quite common, is 2 endpoints. Don't forget 2 endpoints also possibly provide the maximum value or minimum value to you. So 2 endpoints of the domain of f of x. Okay, so sometimes we call these 2 points are critical point. Critical, that means we can say it's very important. But don't forget, this is just a possibly have, not guaranteed it. So you can just use this point as your candidate. If these 3 conditions, one of the 3 conditions just happen, this point can possibly having extreme value, but not guaranteed it. Okay, so this is note 1. And I also want to give you a second note. The second note is the converse of the theorem is false. What's theorem? This one. Okay, here it's a mention if you exist the maximum value or minimum value at some integer point C, and f prime s is defined as C, then f prime C is 0. F prime of C is 0. But inverse, what is the inverse? If f prime C is 0, f of C can provide maximum value or minimum value. It's not always true. It's not always true. OK， 我们白话讲一次啊，用中文讲一次。一阶导数为0的地方，等一下，这一阶如果它一阶导数存在在 C， 而且呢，它是内部的点，而且它能够产出极大或极小值。好，我先确定它有极大或极小值了，那我可以确定它的一次导数为0。反过来，一次导数为0，是不是代表它一定有极大或极小值？未必。这就是我这个第二个 note 想讲的。The converse of a theorem is false， 不是总是对的。它有时候是对的，没有错。但它会有老鼠屎说它不对的。就是说，所以你只能说一阶导数为0的地方，我可能有极大值、极小值，你要多做一点判断。但是它提供了一些可能的点给你而已，不是代表它一定有。但是反过来，如果你可以确保这个点已经有极大或极小值了，而且它是可以微分的，我敢保证它一定一次微分为0。这样了解吗？所以千万不要把这个方向，因为它不是一个 if and only if 的条件，不是 A 可以推到 B，B 同时也可以推回到 A 的，不是，它只有单向的，它只有 A 到 B 这个条件而已。注意看，它只有你是极大值、极小值，可微分，内部的点，你的一次导数我确定为0，但是一次导数为0未必确保你有极大或极小值。Okay, for example, I can give you some example that like f of x is equal to s cubed. So f prime x should be 3s squared. So that you can see f prime 0 is equal to 0. But if you just look at the curve will just something like this one. You can see here, this is f, this s is equal to 0. So you can see its f prime of 0 is also 0. But did you see any maximum value or minimum value happens here? No, right? Actually, this is a reflection point, but later on we will discuss this part. But you can see even f prime of 0 is equal to 0, but we still can have any maximum value or minimum value here. Okay, so this is an example to show that. So then, conclude this theorem, we can get some strategy. How to find the absolute extreme values of a continuous function f of s on a finite closed interval. How can you do that? So there are two steps. Step 1 is try to evaluate f of s at all critical points and endpoint. So like I say, there are 3 types of candidate. One is the critical point, and the other one is endpoint. But for critical point, there are 2 types, subtype. One is first derivative is equal to 0, or first derivative is undefined. Undefined is also possible. Okay, undefined just like this one. something like something like this one. Then here is undefined, but it's possibly can have a extreme value here, right? Something like that. Okay, so this is the first step. Try to find all critical points and the end point. Then take the largest one and smallest one of this value. So we already list out some candidates. 我们已经列出了许多的候选人，对不对？但是候选人呢，我们还不用他是说是，我们只知道他可能是区域的极大，可能是区域的极小，或者甚至什么都不是。哦，像刚刚有讲过了，一次微分为零不代表，但是起码它是有可能发生，它起码可能是候选人。哦，另外一个不要忘了两个端点，你看。如果我刚刚在这个例子里面，我画上两个端点，对不对？我只 focus 在这个 A 跟 B， 你会发现在这里的时候，其实我是区域极大。我在靠近它的时候，其实已经没有人比我高了，它是区域极大。同样的，到了这里的时候呢，没有人比我低了，我是区域极小。所以这些点，这些点，这些点。我们都来列入考虑。以这个例子啊，画的虽然不很好看，但是两个端点，还有谁？这个点，这个点，这个点，这个点，这四个点，你刚说它应该是一次微分为，这两个点是 n 号，就把它总共6点纳入考虑，去比大小，就可以知道。好，我们现在是用最土法炼钢的方式取得极大极小，但后面会有啊哈。不过就是我们考试的时候会讲说，你这部分你只能用什么哈？就是比方说这个只能用，比方说我们在这边是1/4吧哈，1/4，我们就会请大家还是用这种比较暴力法去取得极大或极小值。当然后面我们会有1阶导数、2阶导数的帮忙的时候，我们再用那种方法去做，就好像我教大家数学，当然你可以一下子就有什么微分的公式啊去解。可是我觉得说，应该慢慢的按部就班的把那基本的定义，从极限，从它的这个导数的概念，慢慢去定义出来。那到最后你这样直接用公式了嘛？到最后你这样就用你的手机了嘛？到时候你这样用 ChatGPT 嘛？但是基本的动作，我们应该把它熟悉一次，对不对？就好像我这样讲，现在的人应该不会跟汽车去比赛跑吧？对不对？不会跟摩托车去比赛跑嘛？因为根本你就赢不了他嘛，对不对？但是基本上你不要忘了你的基本走路的能力，对不对？好 ，OK， so I will give you an example. So if f of s is defined as s to the power of 2/3 this interval -2 to 3. So can you just find its extreme value? Can you just find its extreme value? So basically, if you just draw it, you can see the figure is just like this one. This is -2, and this is +3. So the first step is we need to try to find its critical point. So if f of s is equal to s to the power of 2/3, so let's just take its first derivative, then we can get finally we can get this one. So it will be 2/3 times finally we can get this one, okay? And then you can see based on this, then we can conclude that when s is equal to 0, because this is a cubic root, right? So s is equal to 0, that will cause f prime x is undefined, right? Then we can conclude that therefore s equal to 0 is a critical point. The only critical point, right? We don't have f prime x is equal to 0. We just have f prime x is undefined. Of course, it possibly has many points which critical point just happen there. However, in this case, we just have 0 only. Okay. Then besides, we have two endpoints that including s is equal to -2 and s is equal to 3 because of here, right? So this one is the only critical point. These two ones are the endpoints. So we need to consider these 3 points so that we can start to evaluate its value. So if s is equal to 0, then we can get f of 0 is 0, right? So for the two endpoints, s is equal to -2, s is equal to 3, then we can get f of -2 should be third root of 4, then f of 3 is third of 9. So finally, we can see this is the absolute maximum value, and this one is absolute minimum value. Okay, finally, we just pick this point. So you can see that the fourth point is here. This is the minimum, right? And for the maximum should be here. Happen at x is equal to 3. So you just list them out, all candidate points out, and then try to evaluate all points, the value at these candidate points. Then finally you can find its maximum value and minimum value, and that will be the absolute minima and absolute maxima. Okay, this is for section 1. Okay. So in this section, you can just use first derivative as a reference to try to pick some possible point which can provide the maximum value or minimum value. Of course, you also can take the two endpoints into consideration. So as for section 2, we will talk about this theorem is also very important. We call it mean value theorem. The so-called mean value is 中间值定理，均值定理，均值定理，平均值 ，sorry, it should be 均值。So 均值定理。So compared to what we learned is intermediate theorem. They are different. OK， 这是中间值定理。要区隔哈。 不要把它搞混了啊。我们现在讲的是均值定理啊，这个也是非常重要的定理哈。这个会建构了后面的积分的基础哦。但是跟中间值定理不一样哈，中间值的定理是它介于中间的意思，均值是取平均的意思。Okay. So before we go for the mean value theorem, then we need to learn Rolle's theorem first. Actually, Rolle's theory is a fundamental part for mean value theorem. So what is the Rolle's? If y is equal to f of s is continuous at every point of AB. So that means in some certain interval A and B, we can make sure f of s is continuous. Okay? Then we also say it is differentiable in this at every point of AB. So we can notice that this is a cross interval, this is an open interval. So when we talk about the differentiable, we just focus on its interior point only. Okay? So in this case, if f of A is equal to f of B, then there is at least one number C in AB, and at which f prime C is equal to 0. So I can, before we go to break, I can show you something like that. Okay, if there is a curve, this is y is equal to f of s. We just focus on some certain point A and B. We just know f of A and f of B have the same value. So in this case, we will say at least one point C inside AB its first derivative should be 0. Of course, you can try. This is going up then going down. It may possibly be going down then going up, right? So I just showed the case like this one to you, but of course you can conduct another example that going down then going up, then we still can find C is within A and B, then f prime C is equal to 0. So, okay, maybe another possibility is just like this one. If the function is much more than the simple one, maybe something like this one, right? So if we still focus on some certain point A and some B, we just focus on this one because these two ones have the same function value. So you can see at least one. So here we just have one. But here, how many C can satisfy the f prime C is equal to 0? 3. Because here, also here, right? You can notice that the tangent point at these 3 points are horizontal and its slope is 0. Okay, so let's just stop here for a while, and then after 10 minutes, we just come back to the classroom. Before we go for the mean value theorem, maybe I just give you an example to see how can we just use the Rolle's theorem. So this example is just like that. Please just show that s cubed plus 3x plus 1 is equal to 0 has exactly one root of real numbers. So I believe we also faced the same problem before earlier, right? At that time, we just asked you simply show there exist roots there. We didn't ask you how many, right? But in this case, this problem just asks us to show that there is just exactly one. Exactly one. So actually, for the beginning, it's just same before that when we just use the intermediate theorem. For example, if we just let f of x is equal to s cubed plus 3x plus 1, then okay, we can try to find. Did you remember at that time we just try to find some x which can make the function to get a positive number return. Then we try to find another point that can make the function value to get a negative number. So for example, it's not always like that, but you can pick 0. For me, I like to pick 0. Why? Because I can simply ignore the calculation for any term with x, right? So in this case, that should be 1, right? So this is a positive. Then we try to find another point. For example, maybe I try -1. Of course, you can try -2. But our purpose is try to find some point which can make the function get a negative value. Okay, so if we try -1, then we can get, that will be -1 to the power 3 plus 3 times -1 plus 1. So the final result is -3. So see, we get the negative return. So in between, to positive to negative, we can use him by the intermediate theorem, right? So we definitely can find 1c in 0 to, sorry, -1, -1 to 0, such that f of c should equal to 0, right? So at that time, we can say, we can find, but we didn't say how many c, right? We just said, I can guarantee you can find c, at least 1, at least 1. But we cannot guarantee, I cannot tell you that how many. Maybe going up and going down, and going up again and going down. So maybe 1, 3, maybe they are possible, right? So in this case, so far we can just conclude that we only can conclude that we have at least one root in this interval. right? So this is the first step. So we just, for the first step, it's almost the same what we have done in when we just learn the intermediate theorem, right? But okay, the second one is because this question just asks us to show that there is just exactly one. So we cannot just stop here. If we just stop here, we just say, okay, we have roots, but I just don't know how many roots. But the question just asks you more, that can you just show me you can just have exactly one root? So we can continue, we should continue. So we assume there are two more roots of real number. Okay, so if we say we assume, this is assumption. So later on, I will show your assumption is wrong. Your assumption is wrong. So, but in the beginning, we just assume there are two more roots, right? So two more roots, that means, okay, two more, that means at least you can have S1 and S2, right? Because two more. So if these two ones are roots, we can say that f of S1 is equal to 0, right? And at the same time, since S2 is also root, so f of S2 should be also 0, right? Because they are roots. We assume these two ones are roots. So of course, when we just put it as an input for the function, we can get the return value as 0. Okay, then by the Rolle's theorem, we can find a C in, you can see Rolle's just say that we can find one point between A and B, right, in S1 and S2, such that f of C, when we calculate its prime, should be 0, right? Then C is in between S1 and S2, right? Don't forget to put prime, because Rolle's just told us that if f of A and f of B is equal, we can find a C which C is between A and B, f prime C is equal to 0. Remember, f prime C is slope. Its slope of tangents should be 0. Okay, so in this case, if f is 1, f is 2 are zeros, then we can find C in S1, S2, such that f prime C is equal to, this is by Rolle's. So, however, f prime x is equal to 3x squared plus 3, right? So any point here, it will larger or equal to 0, right? So based on this, that we're always positive. Always positive. So no matter you put any x in f prime x, that your number should be larger than 0. But by the conclusion here, you say f prime c is 0. So there is conflict. So there exists a conflict with 2. Hence, the assumption so the assumption is wrong, so we only can have one root for f of s equal to 0. Okay, so 3 stage. Let me just quickly repeat it again. 这个题目呢，跟我们当初在学均子定理的时候其实是一样的，但是差别是它这次更进一步的说，你可以确保的根只有一个。所以在第一步骤呢，其实是一样的，对不对？第一步就是我找一个，因为它是连续函数嘛，对不对？连续函数呢，它有一个点代进去是大于零，一个点代进去小于零，那一定中间就怎么样？不管是正到负或负到正呢，你一定会有一个点呢是经过零的，过零的那个部分就是你的根，对不对？所以第一件事情其实跟你以前做的没有不一样，一模一样。但是第一件事，第一个只证明的部分只说明了说，我敢说零到负1到0之间有根，可是没有确保说它会不会上下来回好几个根。所以你只能说这里有根，但是我不能确保它有几个根，至少有一个根。那第二个是说，好，那他既然说我要确立它只有一个根，简单的做法是，我先假设它有2个以上的根，最少是2个嘛，2个以上。如果这件事情只要被否决了，又加上它一定有根，对不对？一定有根就是不是零嘛。那2个以上被否决了，那只剩下一个根是成立，对不对？第一个 statement， 第一个子题证明的是有根，代表什么？一定1以上，1、2、3、4、6、7、8、9更多，对不对？但第二个，我就假设我想办法突破2个根以上是一个错误的假设，我就说，我有2个根。好，那时候2个根代表什么？既然是根什么，带进去应该什么？都为0嘛。根据 Rose 定理告诉我什么？如果你2个等高，这2个正等高都在0是等高。Rose 告诉我们的等高，等高的过程当中呢，一定会有经过一次微分为0的那个点。所以既然是等高都是0呢，那一定呢怎么样？会找到一个 C 的点，介于 S1 跟 S2 之间，使得它的一次微分 C 为0。这是 Rose 告诉我们的。但是呢，你如果试着去把这 f of s 去微分呢，它会出现 3s 平方加3，对不对？我们知道任何数的平方，任何实数的平方，它一定是什么正的，最多是0，所以它不可能是0的，因为它还有一个加3这个常数，所以就出现所谓的冲突了，这边就冲突了，这个跟这个就冲突了。冲突结果代表什么？你2的假设是一个错的假设，2假设这个错代表什么？它不可能有2个以上的根，那代表什么？排除掉它没有根，排除掉它有2个根以上，那就只剩1个根，这样了解吗？这逻辑是这样子铺的啦，哈。OK， so let's just continue. Then we will go into the mean value theorem. This is a very important theorem. So suppose y is equal to f of s is, you can see the assumption is the same, is continuous on the closed interval AB and differentiable on open interval AB. They are almost the same assumption. Then there is at least one point C between AB at which f of B minus f of A divided by B minus A is equal to f prime C. Maybe when you just look at it for your first time, it's a little bit complex, right? Because there is a relation for the slope, and this is also its derivative. But actually, after I just draw the picture for you, and then you can easily to memorize it. The idea is just like this one, S, Y, right? So if we have a function something like this one, so right now we have a point A here, so that we have f of A. Then we have a second point B here. Then we also have f of B, right? B here. So what do we mean by this one? So this one is about calculating the slope when we just link these 2 points together. So did you notice that actually this is its slope? Right? Its slope for the line connecting these 2 points. A f of A, B f of B, right? When we just connect them by using this green line, then we can get its slope is like this one. Okay? So based on the description for the mean value theorem, actually it's just about that you can at least find 1 point. For example, what point? This point, C, its slope is f prime C, same as this one, right? And we also have another possible point, maybe somehow here, C prime. Its slope is f prime C prime, right? They have the same slope. In this case, we have 2 points, C and C prime. Their slope, their derivatives are same as the slope. OK， 好，我解释一下哈。其实课本有证明，也是证明的非常漂亮，但是其实它就一个技巧而已。大家头稍微转弯一下，转过来，如果做了坐标转换，你会发现，啊，它变成这样子，头要弯两个角度，应该像你这样，对不对？要歪这个角度。你们，你就把歪这个角度看，这两个是不是等高？不要以为在讲笑哎。来，把扭一下，是不是像这个一样？像这个一样，很高，这里很高，这头稍微转一下，运动一下，对不对？避免睡着，对不对？头稍微转动一下。其实你回去看一下课本的证明，事实上就是我刚这样子转动一下就证明。转过来，你会发现这两个等高，它变水平线，对不对？这两条线是不是也变水平线？这是代表它的斜率跟它斜率都是0。我是说转过来就做了转换之后，那你再把它还原回来的时候，基本上的道理是一样的。就是我这两条线的斜率，这两个点连接斜率应该是，我们都知道两点之间斜率是用这样算，这斜率没问题吧？没问题，对不对？这个是它的切线的导数，这是它的导数，也就是它的切线斜率，这个也是相等。所以这个应该等于，我们至少会找到一个点，跟它的连接的斜率是一样的。 So actually, Rolle's theorem is a very special case for mean value theorem, especially f of a and f of b have the same value. But in this case, it's more general because in this case, f of a and f of b is not necessarily the same. Okay? So you can just follow, okay, for the left-hand side is the slope for the line which connect these 2 points. For the right-hand side, f prime of c means you can find at least 1 point which can provide the same value, same slope as this one. Okay, here also f prime, c prime. Okay, so as I told you, this is a very important theorem. So we can use this as a basis to derive many good theorems. Sometimes we call it corollary. Corollary 1. Corollary means it's not so big as a theorem, but based on this theorem, we can derive some good facts. Okay, for first one, if f prime x is equal to 0, then f of s if f of x if f prime x is equal to 0 at each point x in AB, then we can conclude that f of x should be a constant function for all x belongs to AB. This is a very important result because actually, based on this fact, we start to understand the integration, even though so far we still focus on differentiation, but actually this kind of start to look at the integration. So, okay, here, if we know f prime x is equal to 0 for all points at this interval, then we can conclude f of x must be a constant function. That means f of x is equal to constant for all x belongs to this interval. So how can we just prove it by using the mean value theorem? So by the mean value theorem, for any x1 and x2 in AB, we can find x between s1 and s2 such that f prime s is equal to f of s2 minus f of s1 divided by s2 minus s1. Right? This is provided by the correlate, by the mean value theorem. Right? Mean value theorem says that if there are 2 points, then we can find a point between these 2 endpoints such that its slope its derivative is equal to the slope of the line connecting these 2 endpoints. 记得吗？看一下这上面这张图，对不对？任何2个点之间连线的斜率，我一定可以找到至少有一个点 C， 它的导数，它的微分值会跟你这斜率的值是一模一样的，所以这到目前为止都是这个均值定理告诉我们的。好， Okay, so based on this, we already, based on the mean value theorem, we know that, right? We can have this one. But don't forget, if f prime s is equal to 0, so that means this is equal to 0, right? This field is provided by the statement here, f prime s is equal to 0. So f prime s should be 0, so that you can see, since S2 is different from S1, so here should be 0, right? So that we can have f of S2 minus f of S1 should be 0. Then finally, we can get f of S2 is always equal to f of S1. So if any point, different point, always can have the same return value, function value, only constant function can do that, right? So in this case, we can conclude that f of s must be constant,好，我很快讲一下哦，前面这边没问题，对，任何两点之间的连线的斜率，我一定可以找到这个点介于这两个端点之间，它的导数，看这张图，它的导数一定会等于至少一个点，会等于这两条线连线的斜率，对不对？所以这条事实是在告诉我们这件事情。好，那题目同时也告诉我们说 ，f prime x 永远是零啊，在这个区间永远是零，在这个区间，所以这件事情是永远为零。OK， 所以永远为零，在 S2 跟 S1 不相等的情况之下，只有什么？这个本来就不会相等哦，你取3个点就没有意思，对不对？所以 S2 减到 S1 ，f of S1 呢应该要等于，所以 f of S2 就会等于 f of S1。所以什么时候什么函数会让你有，不管你带什么点进去，它们都函数都很相等，只有常数函数，只有常数函数做到这件事情是，你不管放什么进去，它永远都是相等嘛。好，所以这件事情就证明说，当你以次为分，在某个区域，这也是很重要的结果哦。虽然证明是要，我要证明给大家看的原因是，我希望重复的强调这个均等定理怎么用。但是其实我还有更大一个企图是让大家记得，如果以次为分为零的区间函数呢，一定是一个在这个区间里面，它们一定保持一个很长的值。哦，这是一个很重要的结果哈。Okay, so this is corollary 1. Then I want to introduce the corollary 2. What is the corollary 2? If this one is a little bit different, if f prime s is equal to g prime s at each point s in AB, then f of x is equal to g of x plus c. So I just list here, you can just make a comparison. The corollary here is a little different, right? Here we assume f prime x is equal to 0. But here we assume if two functions, we just don't know what these two functions are, but we know its first derivative are the same for some certain interval. Based on this, we can conclude f of s and g of s. The only difference in between is a constant. Constant. Okay, so I can just we can prove it. we can just take h of s is equal to f of s minus g of s. So we just differentiate at both sides. So we can have f prime s is equal to f prime s minus g prime s, right? Because it's just that f of s would be the difference of f of s and g of s. So once we just differentiate both sides at the same time, then we can get this one. Then since this just provides us that it is equal to 0, right? So that we can conclude that h of x is equal to c because of corollary 1. Because corollary 1 just told us that if some function is first derivative is equal to 0, we can conclude its original function should be a constant. So that we can continue to conclude that f of s minus g of s is equal to c. So that finally f of s is equal to g of s plus c. 好，第二个引理呢，跟第一个有点类似，事实上它也是来自第一个引理所得到的结果。你看看，第二个告诉我们是什么？我有两个函数 f of s 跟 g of s， 可是我没有告诉你它原生长什么样子哦。这很重要，这也是我们后面讲反导函数或者积分的很重要的基础。我不知道它函数 f of s 跟 g of s 长什么样，但是我告诉你，一次导数跟它一次导数是相反，也就是我微分之后，它们两个有相同的结果，只是我不知道它原来的函数长什么样。好，假如你有这种条件，那么 f 跟 g of s 之间呢，它们只会差一个 c 的常数的差距而已。那这原理很简单，它来自引理一，这证明就是到两相减，它需要一起取微分，然后因为 h prime s 是等于零，所以呢 h prime s 应该等于 c。注意哦，你不要搞混哦，这边是有 prime 的哦，这边是没有的哦。所以一次微分为零的函数，它必定是 f of s， 一定是一个常数函数，对，常数函数未必是零哦。OK， 所以呢，我再把它还原，就知道函数 f 跟 g 之间呢，它就差一个 c。那这有什么用呢？ This is a very important result we can use for antiderivative, but later, only right now we are in chapter 4, then only when we just move to chapter 5, we will talk about in this chapter we will talk about antiderivative. Then chapter 5 we will start to touch integration, but they are some kind of the same. Okay, so before that, I give you an example. Please just find the function f of x whose derivative is sine x, okay, and whose graph passes through 0, 2. Okay, please just tell me what the function f of x is. Okay, so the condition is because we know based on this, we know f prime x. Because of this, we know f prime x is equal to sine x, right? Because based on this equation, it didn't tell us what f(x) is, but it provides us that its derivative is sine x, right? So f prime x is equal to sine x. And at the same time, we also know that if g of s is equal to negative cosine x, then we can have g prime s is sine x, right? Why? If we want to have g prime s is equal to sine x, we know if we assign g of s is equal to negative cosine x, but we take the derivative, then we can get sine x. Why we do that? Because if so, you can see they have the same derivative. Here is sine, here is also sine. So we can just try to apply corollary to solve this problem. So therefore, since they have the same first derivative, based on the corollary 2 that we know f of s must be cosine negative cosine s, that means this is g of s plus c, right? According to corollary 2 by the corollary 2, right? And especially for the second condition, whose graph passing through 0, 2. So that means when we use 0 as the input, the result should be 2, right? Because they just passing this point, right? So we can continue to get negative cosine 0 plus c should be 2, so that we can get c is equal to 3. Then finally, we can get f of s should be negative cosine s plus 3.好，这个题目呢，我可以多花一点时间讲一下，是因为这个跟我们第4至8要讲的反导函数会有点关系哈，所以先讲的让大家有些，虽然这个很简单，但是呢，还是先讲一下。好，我们1、2告诉我们什么？如果两个函数原生函数我不知道什么，但是我知道它一次导数是相同的话，我们知道两个函数之间的原生，我讲原生就是原来的6微分的这个 f(x)， 会跟它的原生的函数会只差一个7的关系。注意看哦，所以我现在呢，我只知道 f(x)， 我不知道 f(x) 长怎样，但是我知道 f prime x 是 sin x， 所以我如果要找出 f(x)， 最好的方法是什么？我去找出某个函数，它的一次导数刚好是 sin x， 那我是不是就可以来用这个定理2？那谁的一阶导数会等于 sin x 呢？只有在 g of s 等于，当然它可以加什么常数，就是最一般的就是 g of s 等于负的 cosine x， 它的一次导数刚好会等于 sin x。我找它出来的目的是干什么？找它出来之后，因为你们两个呢有相同的一次导数 ，f of s 跟 g of s 呢有一次相同的一次导数，它的原生函数就是负微分这一块呢，就会只差一个7的关系。所以我知道 f of s， 我不知道 f of s 长什么样子，但是它的导数跟它这个函数的一次导数是相同的，所以我就可以知道，哦，原来 f of s 是 g of s 加7的，我就可以知道，哦 f of s 应该长这样子。那这个题目有更特殊的告诉你说，其实不仅这样哦，我还知道这个函数会经过0、2这个点，所以0、2这个点0带进去呢，我就知道它是2，所以这 c 就决定了。其实这个是一个非常基础的微分方程式，非常基础的微分方程式。 因为你看看哦，我告诉你的这个函数，我没有告诉你它的实际上的长相，但是我告诉你它的解法是什么。所以你要解出它的原生函数，事实上这就是维望程式。那维望程式的解其实有很多解，那我再告诉你一个，这个在维望程式叫做初始条件 （initial condition）。我给你初始条件之后，我就可以多中选一的唯一决定你的函数长相是什么样。最后你的函数 f 就是负的 cos x 加3。哦，那这个是我们48到时候讲的反导函数很重要的一个基础哈。Okay, so this is section 2. So any questions so far? 好像变得很热哈，还是天气变好了吗 ？Okay, so we still have 4 minutes. So let me just slightly introduce section 3. That we will talk about the monotonic function. Monotonic means 单调函数 and the first derivative test. Okay, so let's just go for the monotonic function first. So what is monotonic function? There are two types of monotonic function. One is increasing, one is decreasing. These two types. Okay, so let f of s be a function defined on an interval I. Okay, so that means we just focus on some spatial interval I. We now always needed to pay attention to the whole domain. We just focus on some interval I instead of its natural domain. Okay. And if there are 2 points S1 and S2 are 2 points in I. So that means in this interval I just pick up 1 point S1 and the other point is S2. First, if f of S1 always less than f of S2, whenever S1 less than S2, then we will say f of S is increasing in I. Remember, we just focus on I instead of whole complete domain, okay? And the second one, if f of S1 always larger than f of S2, whenever S1 less than S2, then we will say f of S is decreasing in I. So again, we just focus on I interval. So if a function that is either increasing or decreasing on this interval I, we call it monotonic in I. 好，结束前我最后刚才讲一下哈，因为这两个定义其实还蛮简单的。好，这是递增递减，就是所谓的单调函数哈。单调就是说它只会递增，在这个区间它只会递增，在某区间只会递减，它的行为就是只有一个方向。 不会上上下下的。所以我们会强调，假若呢，只要 S1 比 S2 来的小，就你会想象哦，这 S1 跟 S2，你这句话从后面先看过来 ，S1 比 S2 小的时候，一定确保 S1 的函数值的 F2 的函数值呢，它还是小于它，这种的我们称之递增函数。注意在这个区间。同样的，如果 S 越来越大，反而它的函数值是越来越小。那在这个区间，注意我在讲哦，我是讲这个区间而已啊，它会是递减。所以，假如一个函数在某一个区间里面，它拥有一直递增或者就是一直递减，我们就称之它在 I 里面它有一个单调的系统，单调的递增和单调递减。那先跟大家预告，要告诉大家这是什么。当我们有一个陡面出来之后，我可以把它切成好几段，对不对？某一段它搞不好一直发了这种单调递增，某一段一直单调递减。那大家想想，如果某一段它会单调递增，经过这一个点会单调递减，代表什么？会发生什么？极大值，发生极大值。它如果会递增，单调的递增，又单调的递减，过了这个点之后，是发生极大值。就同样的，如果在某个区间它单调的递减，透过某个点之后它单调的递增几小时，所以这个大家会觉得，哎，老师这 increasing decreasing 我们学过了，可这里在告诉你区域之某一个区间里面它是递增或递减的，可以帮助你去选择、去判断它是极大或极小。好，我们今天这样，礼拜三我们再继续介绍哈。是，
可以解释。